Hello everyone, this is Rahul John, and today I'll be discussing the collab which I have generated from ChatGPT. So what we have done here is we have done intense data science on a Kaggle data set called Heart, which is a pretty famous data set. And the complete code is written by ChatGPT, and we have leveraged ChatGPT to do data science. And we'll begin with discussing what we have done in the collab, what basically ChatGPT has done with the collab. So we'll begin with importing necessary libraries, and we have uploaded the hard disk's UCI CSV file. And then we read by Pandas library, and we'll try to figure out what are the null values present in this. And what our goal will be is to predict this num. This will be the target value basically, and we'll try to understand and pre-process the data. So here we are again doing the same. We are trying to find out how many null values we have. So we have null values for these many columns, and we'll try to fix that, and we'll encode the categorical column, a categorical variable if there are present. So we'll fix that, and we'll separate features and the target variables as well. So we'll for the x, we'll try to drop the num, and we'll have a data frame which is y, and which will specifically have the num variable, num column. So we'll split the data set into train and test, and we'll have X train as the training data set, and we'll test over the X test, and we'll use the Y train as the prediction value, and we'll test with Y test. So we have splitted the data, we have dropped num column for X, and so on. So we have available training set as 736, and we have test set as 184. So after that, it also says that we have 22 columns that will be used for model making. And now we'll try to scale the data and fit the scaler on the training data and transform both the training and testing sets. So we'll check the shape of the scale data, and once it is done, we have the scale data with us, which has a dimension as 736 is into 22. So we'll go with the baseline model, which is the logistic regression model, and we'll do and make the confusion matrix for it and try to pick up the values that are most relevant to the num. And for this, we get a precision of 0.34, which is a low precision. And we'll try to define the hyperparameter grids here, and then we'll initialize the logistic regression model, and we'll set the iterator for 1000, and then we'll do a grid search where we'll be sending logistic regression model and the scoring of accuracy that we obtained from the previous code, and we'll try to get the grid search here, and we'll fit the data and perform the grid search, and then we'll compute and print the ROC accuracy score for multi-class classification. So here we get a precision of 0.36, which is better, and because we did the tuning. And now we'll train and evaluate the random forest classifier model, and we'll just use 100 estimators, and we'll fit the data, the scaled values which we have, and then we'll perform the multi-class classification, and we'll try to evaluate the SVM model as well. So further we go, and we see we have a precision of 0.72, which is 72%, and we have the same precision for SVM as well. And now we'll see the confusion matrix for random forest classifier, which is pretty decent. And now we'll go to hyperparameter tuning for SVM using grid search CV. So we'll try to initialize SVM model. So as I prior mentioned that this is completely done by ChatGPT. So I just gave it some prompt and I said that this is a data set you have, and as a world-renowned data scientist, you have to perform data science over this model. So, as a world-renowned data scientist, you have to perform data science on this heart disease, excuse me, heart disease data set. And this is what the code it has given to me. And we'll see, like we'll try to use the already tuned logistic regression model here, and then we'll evaluate the logistic regression model. So we get a precision of 0.63, and but the accuracy is not that great for the logistic regression model. It is slightly better for SVM model, and then it is followed by the gradient boosting classifier. I think it performed a little better than SVM model here, and then we'll try to score. So the logistic regression ROC accuracy value is 82% and SVM is 83% and gradient boosting is 84%. So I think it is pretty clear that gradient boosting is the winner, and we'll try to save that model, gradient boosting model. So that's all for this video. I hope you enjoyed this video and you learned something out of this. Thanks for watching, and like and share the video.